Hi there guys, it's time to wrap up this particular experiment which has been going for about a year now, believe it or not, and its principal design was to compare a first stage precipitate run up to 10.7 and then washed, and with the second stage precipitate where it's taken back down to pH of 1 and then up to 8.5, 8.7, with the third stage precipitate where this is done another time. And the idea being is to compare how much precipitate we got in each stage and try and do a couple more experiments after this to see whether there was any difference in the precipitate. The idea that's beginning to emerge in my mind from the experiments is what you see with your eye is mostly magnesium hydroxide, and the reason why it's less on the second stage precipitate is of course because you're not going to quite as high pH, and it's supposedly that it's end state that you're getting. But it's begun to emerge that even though you're not going above pH of 9, then it is still mostly magnesium hydroxide. This one went haywire. You can see all the extra tags on there. That's because the experiment went haywire, and these were originally timed to finish about the same time, which happened to be in May, believe it or not, after having started well earlier in the year. And now it's December, so this experiment went haywire, and these have been sitting there washed since May, and it's now December, and I've just finished this one. So this precipitate that's in here, even though it's got a couple extra washes to go, has not settled as far. The jar sizes are slightly different, but I expect this one to, if I left this for 6 months, to settle nearly half as much and be a bit more than this but less than this one. But overall it's a bit contaminated in terms of what went wrong. And chiefly it just overran. I was trying to go very slow on the precipitation, and what happened was it overshot, which really underscores the point that for doing it at home, the more processes you put in place, then the harder it is to do it without it going wrong, particularly around the change in the pH. It's so steep that if your reaction is taking some weeks, yes, some weeks, and you're not there the very minute that it's starts to go across the pH scale, then you're going to miss it. It's going to overshoot, and that's what happened in that case. And so I had to take it back and start again. But it appears to my eye that I was not successful in reducing the amount of magnesium hydroxide that was produced. And so I'll probably be calling this experiment to close. I'll give you a quick look at the plan for the experiment and the flowchart, and then compare that with the flowchart of what actually happened, and then you can get into watching some of the more interesting things that happened in the experiment. In particular, it came into the solution very slowly, but it formed like a tubule, and what I imagine is happening is the sodium hydroxide is going down the centre. It's sort of like an ocean tube from a vent on the ocean floor, and this liquid's coming through the centre and it's building up on the edge, so you've got a flow of hydroxide down through the middle, and it grows a tubule, even, believe it or not, till it actually touched the bottom of the container. Quite interesting in itself to see that. So enjoy, guys. Well, here's the plan. We've got 3 samples. The first one stopping at the first stage of precipitation, so it would come all the way through. The second one and the third one going on to a second stage of precipitation, and then that one following all the way through, and lastly one going back to pH 1 again, and for a third stage precipitation. All standard sort of stuff. The idea was that we could then compare the Ormus from each of those 3 stages. Now for what actually happened. The first stage precipitate and the second stage precipitate by and large went through without incident. One that required 3 stages, then a very large nodule formed, which I thought, oh, I can't leave that out, and I can't put it in, there could be something different about it. So I split the sample and followed on from there, and going from the second to the third stage, then believe it or not, both of them overshot, which is pretty easy to do. so it went past 8.5 to 12, which was very disappointing, but easy to do when it's taking 2 weeks or more to get there. Then you can really miss the real deal. It just changes so quick, the pH. Anyway, the nodule one, I decided to rack that off and just take the solution through under the premise that the M state is likely to be dissolved, and I'll just take it through to 8.5 and 10.7 and on through. And so I did that quite without incident. The main line, then I took that all the way back to pH 1, and that was problematic because it didn't fully clear, and so I split the sample into 3 and tried 3 different treatments. One I heated, and the other I also heated, but one of them I added more water to it and let them settle, and so that was then racked off, and then that created a sample that had been racked off, namely the lees, which I added more water to again and maintained at pH 1 to see if it would clear, and ultimately left all of them like another 6 months to see if those other 3 would clear, and indeed these were kind of murky. They were basically dissolved. This sample here, the one that was just heated, it was not clear at all even after 6 months, so I discarded that one. And these other ones, they were clear, but they needed to be racked, particularly a couple of them. So I racked where it needed to be racked, combined them all together and brought them on through to pH 8.5, and then combined these 2 together. So look, I'm a great believer in warts and all, just showing exactly what did happen, and if you watch the videos now, you'll see the exciting Ormus tubules that formed, and I'll try and leave out all this regular stuff, just try and speed it up as quick as possible, that you can see basically what happened. Our sample was washed and taken down to 1.0 on the 18th of the 3rd. It's the 1st of the 4th now, so it's been more than 2 weeks. And you can see my little piggy back there with a chemical bridge. A few shoelaces twisted together, drooped over to the top, down into the solution, and you can see a cloudiness, and I don't know if it'll come up very well, but there is precipitate on the bottom, and it seems to have been forming underneath the wick and the bridge and just dropping onto the bottom of the jar. I'll just see if we can get a better view from this angle. Yeah, I think you can see bits and pieces down the bottom there. Now the interesting thing is that after 2 weeks, and let's see if I can get this in the shot. Now pH is sitting only at 2.6 after 2 weeks. So even with it going that slowly, there is some kind of precipitate there. We'll stay tuned, we'll take that up to 8.5 and see how long it takes. We're up to day 17. You can see there's quite a bit of murkiness there. You can see it's stratified, it's clearer up the top than down the bottom. You can see a sediment that's not even on the bottom. If I come around here, then where the wick is, that's where it's deepest, so there is precipitation that's occurring in the area of the wick where the sodium hydroxide would be strongest. Just navigating this. See the pH is up to 5.8, 5.9. So it can progress quite quickly from this point, so it may even go to 8.5 today, so I'll need to keep an eye on that. Looking in the top, my wick comes down. I've wrapped my wick in glad wrap just to stop evaporation. You can see it's sort of ballooned out a little bit down the bottom, and I'm not sure how clear that is, but I can get it to focus a bit better. Then there is a bit of precipitate that's caught up inside that. That black would be dye coming out of the out of the shoelaces. Well, it's day 18. It's only sitting at 5.6, which surprised me. And I don't know if you can see the solution in that little piggyback bowl there. I've just lifted it up so it'll start soaking through a bit faster. You can see the bulb, it's growing. It'll be interesting to see what that is. And you can see it's stratified. The sun's coming through the window and catching. Still 18 days, a few hours later, we have 6.3. Well, it's about 9 o'clock at night now, it's at the end of the 18th day, and I was having a reading about 8.0, and I thought, oh, I better go and get another pH meter, and it's reading 8.7, so I am going to stop it here. It's interesting what can go wrong. These were both calibrated before this experiment, and they were reading exactly the same, whereas now they're 0.7 difference between them. I was going to take it to 8.5, and it's got to be pretty close. One of them's right, I would guess. Now I'm just trying to show you. I think you can pick that up in that shot. That there, it's not moving, but in the solution you can see some precipitate that's suspended in the solution. Oh, I can see it moving very slowly with my eye, so that's interesting. And the bulb, I think, of precipitate, there it is there. I think I'll carefully put that separate and wash that separate. I'll probably include it back in the mix, but I'm just a bit worried that there might be something funny going on there. I don't want to mix it in if I can help it until it's washed. You can see the precipitate building up there on the bottom. Alright, so let's give this a go. Just going to try and pull that wick out and put it into this jar of water. And hopefully it'll dilute it if it's over strength, so we won't upset any of our results. Alright, so that's it. There's the wick. And shake everything free. The pH of that is going to 10.2, so that was probably a good call. The last shot was 10 o'clock at night odd, and it's now 10 o'clock in the morning 2 days later, so it's really only 36 hours of settling, so it has cleared. And this is the nodule that came out of the sheath that was around the chemical bridge, the wick, and you can see the dye that's come out of it and the sprinkling over the back there. And this was our main jar. You can see there's not a lot of precipitate there, which is the goal, was to reduce the amount of magnesium hydroxide coming out of that solution. So our goal is to do a third stage precipitate by taking this down to pH 1 and coming back again. Straighten it up, gravity will pull all the last drops out of there, clear itself. Just out of habit I give it 2 or 3 quick rinses. Probably really doesn't need it because it's just a wash. It's a good habit to get into. Add a little bit, pre-charge the siphon, drop it in. clamp the siphon in place. Then adjust the height. I always double check the height properly, and I'm also looking that there's no Ormus being sucked up into it, which often happens. You'll just see a little spiral of it disappearing. Can't see any point in leaving that lump there, so I think I'll just crush it up. Both solutions have been brought down to pH 1, and you can see the one that had the lump dissolved in it, or I should say I mashed it up, 120 A2. Then today, 7th of 4th, it is clearing at pH 1. You can see the spatula through the solution, and most of the lumps have been dissolved that I crushed up, so that's going well. This one here, I actually brought that down first, and it's still struggling to clear. Still looks quite milky, the suspension there. Well, you can see that they're both cleared. It's the next day, so it's been about 24 hours. This one I've had to put about 3.5 extra mil in to maintain the pH. This one only half a mil, and they have got a very fine precipitate in the bottom, brownish. Could be dust that's gotten into the sample because it's been several weeks and top's been on off, and yeah, it could be something like that. So I'm not going to let that go through to the next stage, so I'm going to rack both of these off into a separate clean containers. Here's our setup. Piggyback jar just taped on the back there. Same with this one. Now if you're worried about it falling off, you can usually find something just to put under there to support it. Now I've pre-charged each one of these with 50 mils of water, and so I'm going to make up a 50% solution by adding a 50 mils of my normal concentration of 1/3 of a gram per mil of that, which I've covered all that before. So I'll just quickly drop that in. So it's 50 mil in here. There we go, 50 mil. And using my wick, which is just a shoelace twisted together, tied together 3 or 4 times, and wrapped in glad wrap or sandwich wrap, whatever you call it in your country. And it's pre-moistened, so it's wet with plain water, and we just simply drop that in there, like so. And we'll put some glad wrap over the top of that. We've been running for about 10 hours. As you can see, the reclaimed solution from the nodule not showing any precipitation, and the dregs, I guess, the sediment, the bit that I took off is settled. So I will rack that off. You can see the small bit of sediment that's in the bottom. I will rack that off and pour it into there. The main sample has also almost cleared, so I'll rack that off. I'll probably do all that tomorrow and put it in with the main one. But what I really want to show you is look closely onto the inside. Up the top there is the ends of the shoelace, and you can see a column of precipitation down onto the base. Now I've looked very closely at that, and it's got some lumps and bumps in it which don't move, so I really think that that's solid. So I've got like a solid piece. Now what's happened, I think I've used a different shoelace. The shoelace I've used the last few times is in this sample. I made up a new one. even used a white shoelace, and it's just come through a bit quicker. I think maybe I'll put the piggyback jar a little bit high. Just come back to this one. So the piggyback jar, you can see the solution level in the main jar is just above the bottom of the solution jar in the piggyback. You can imagine if you make that difference too great, that little piggyback's too high, the solution will come through too quickly. Which that could be the case in this other one. Look, I'll try and get a shot up under there. I don't know if you can see it. Yeah, I can see it. The little piggyback jar. It's probably not, you've probably got no frame of reference, but it was 100 mil, and it looks to me like it's between 30 and 50 mil. So that was 100 mil at half strength. So just 70 mil coming through very slowly over 10 hours has caused that. So it's seeped through the shoelace, and one of the shoelaces in particular, or whatever it is, and it's obviously heavier, so it's sunk to the bottom. I don't know, I wasn't here watching it happen, so you can see how it's spread out on the bottom. That's just really cool. Here is the same feature 12 hours later. You can see it's pretty much completely dissolved. What you're seeing in there is the ends of the shoelaces where it's tied together. I came out this morning on my way to work, and there was still about another centimetre or two hanging off of that, but I didn't have time to record it, and so I've come in now, and 12 hours later as opposed to 7 or 8 hours later, 6 hours, and if I look up in there you can see the level is not that much less than last night, but at the same time you can see the levels have matched. So from a siphoning point of view, there's less fluid coming through. You would have to say that it was coming through and the precipitate forming in that localized zone quicker than what it could dissolve, if that makes any sense. And intriguingly, I had the idea that it may have even been a tubule. It could have had the precipitate on the outside of a small amount of liquid flowing down. I don't really know that, it's just speculation. It's a little bit contrasty because of the open window, but there's that last little bit coming out, and hopefully you can see just the small amount of sediment that we were excluding. There it goes, that's concluded. So it's just draining into another glass. You can see it's clear, and that'll be going into the main solution. The other one there is done, and I'll just give you a quick zip over here. So I've poured it into this container, and I'll reset up my piggyback with more solution in it and march on towards 8.5. It's not that easy to see, but it is growing again, the tubule. You can just make out a tubule growing again. About 12 hours ago I topped up the little piggyback bottle of sodium hydroxide, and it's definitely growing from the top down. It's so hard to focus it. It's on the other side of the jar, and the focus wants to grab this side of the jar, but it's growing about half the way down. Maybe I'll put my finger in the shot, see if I can do that way. Got to find my finger, there it is. So it starts about there and it ends about there, just on the end of my fingertip. There you go, I managed to turn the jar around without it breaking off, and you can see it quite clearly there. Murphy's Law, it was behind the label, so that's why it's on this angle. You can also see there's quite a bit of precipitate in the bottom of the jar. It's a bit murky otherwise, and the pH is still below 2 at this point, so that's interesting. Here it is, another 6 to 8 hours later, and you can see the tubules grown. You see the nodule on the bottom. That really confirms that it's a tubule, because that's where the concentration will be strongest. If it's slowing down, it may well just form into a nodule at the bottom. You can see how there's a little pile of precipitate underneath that. All very interesting. 120B, second stage precipitate, 6 to the 5th, 8.5 pH. See that there? Some precipitate, and you can see there's a bit of a nodule on the end of the wick as well. Try and get that. (120C), first stage precipitate. Third wash is done. 120A2, some of the noduled harder precipitate redissolved. You can see there's a column down from the wick to the base. The pH is still struggling to come up. See, it's there flashing 1.2, still some ways to go. Something else interesting on this one, you can see there's a stratification, but it's not uniform. It seems to go up. It's clear, but it's got some colour to it. The dye that's out of the shoelace, I believe, as I've seen in past experiments. Just interesting how it's stratified. I'll just try and catch the... You can't quite see it on the other side of the glass. You can see it with the naked eye, but it's just not level. It's interesting. 120A, third stage precipitate. You can see the last measurement was done on 28th of the 4th. It's now the 6th of the 4th. I've been away at a conference, and you can see I have been adding 10 mil at a time, and it was at 2.6 pH. It's around pH 12, which is extremely annoying, even though that says only the 22nd of the 4th. That was the beginning of the third stage. I've already invested 2 months in this, so it's like, oh, massive effort. So I think I'm going to have to take it all the way back to pH 1 and then on up again. Could, if it wasn't above pH 12, I could possibly have racked some of that solution off, because everything I wanted would have been precipitated, but it said that M-state material will dissolve above pH 12, and that's what this is, so very annoying. Getting towards 24 hours on this 120A, taking it back down to pH of 1, and you can see that it's not settling at all. It's more like a suspension, and it should be clear. You would usually clear in about a few hours. pH is sitting at 0.6, and last night, about 12 hours ago, it was down as low as 0.4, even though it had been left at about 1 12 hours before that when I'd left it. So the pH is moving around a bit. It's taken about 130 mil to get to there, which I thought it was going to take that, because I added up how much sodium hydroxide I'd used previous, so I knew it was going to take about the same amount to undo what had been done. So I've got my piggyback of sodium hydroxide on there, but I can't use it. I'm really got to decide what I'm going to do about this suspension. I might leave it for another 24 hours and just watch it, because the pH is moving a little bit, and see what happens then. It's now been 48 hours and solution 120A has not cleared, so I'm going to apply some heat. I'm going to use some water this time, and I'll be tipping it into these two bowls. It may not all fit. I might have to do it in 2 batches, but we'll see. So the way to do this is to put something in the bottom of a saucepan. I haven't got two of those, so I'm just going to use a skewer. Put that in the bottom of that one. A few more bits. Now that's just so that you don't get direct heat on the bottom. You don't want to break your dish, so I'm using a Pyrex dish. I've pre-boiled some water. So what I'll do now is I'll just quickly take my little piggyback off here because it's full of sodium hydroxide, which I didn't get to use. And we'll dip this in here. I have stirred this and it's still at 1.2 pH. It had settled a tiny little bit. Look, it's so tempting to try and fill those, but I won't. And some pre-boiled water. Speed the whole thing up. I'll top that up as well off camera. So pop this in each one of those. Now if you boil it in or simmer it in water like this, you know you're not going to easily get it to boil, which I don't want to do. I don't want to boil it, I just want to apply some heat to see how that's going to fare. I could put a thermometer in there. But if it just is steaming and simmering, you know it's going to be about between 70 and 80 degrees. And that's all I want, so we'll see. They've been at temperature for nearly an hour, or half an hour at temperature. They've been on the heat for an hour. So I'm going to have to go now. You can see there's no real change. So what I'm going to do is I'm going to turn them off the heat, or just turn the heat off. Been about 7 hours, I think. Gee, it doesn't look like it's changed. Doesn't look like it's changed much. Look, it looks similar. Maybe it's a bit thinner. I can see that there's a. You probably can't see that. I think there's a sediment on the bottom of that. Look, I think I can see the sediment on that one as well. Very similar. Looks like aspirin. I'll just check the pH, 0.8. I'll just check this one. Oh, 0.7, 0.8, 0.7. Flashing between 0.8 and 0.7. Stable 0.7. I'll leave that one to settle. And this second one, what I think I will do is I'll add filtered water to this, and just to see if the problem is that there's not room in the solution to dissolve all of this. I think it's 1.9. I might let that settle, and what I'll do is I'll adjust it back to pH 1 once I've added the extra fluid in. Another week has gone by. pH seems to be stable in all three. You can just see some precipitation in the bottom, so the suspension is gradually settling out, so that would be why it's clearing a bit. Even in the two that were heat treated, they seem to be clearing just a little bit. I think I'll just leave it another week. Today's the 19th. After 11 days we're definitely getting some clearing. The sample that wasn't simmered is clearer, but the other two are definitely clearing as well. Yet another week has gone by. It's now the 26th, and you can see that 120A is very clear. 31st of the 5th, been sitting for 3 weeks now, just over. 8th of the 5th to 31st. 120AC seems to be still clearing. You can quite clearly see the precipitate in the bottom, and also the line of the paper across the back there. The larger one not so, because you can't see the precipitous clearly on the bottom, even in the foreground. I might just try something. I might just pull some of that out and centrifuge it. There's our little sample. Just dunked it in there and dried it off, and I've taped the top shut just so there's no nasty accidents. You can see that you can just see the paper line through the bottom, and there's no precipitate in that jar. I've centrifuged it twice and it just doesn't look any different to me. I can't see any precipitate on the bottom. 120A, sample C, we can now see the line across the back of the solution very clearly, so it's clearing very well. And even sample AB, you can see the line quite distinctly across the back, so it's definitely clearing. Time is dragging on. A has long ago cleared, but the two heat treated ones still have not. C's quite clear, you can see a line drawn across the back there. B is also clearing. I can now much more clearly see the line. 120A, A, B and C, we're almost clear. I think I'm going to rack B and C off, and I'll probably put the lees onto pH 1 just out of interest, just to see what happens. Just like that, almost finished. I'm just going to leave a slider down in here. I don't want to get any of the precipitate out. Just go right down to the end. Nice little siphon tube here. Here we go. It's all done. Here's the one that we just racked off. Almost clear, but not quite. Here's the precipitate left behind with a little bit of fluid. It looks to me 50-40, 50-50, maybe 60-40. Dip it into this little smaller one for the purpose of just being able to have a little look at the pH of this. But having stirred it up, then that pH is sitting on 0.9. Look, there's no change, just stirring it up to what it was. So, you know, it may be that that's not magnesium hydroxide. Really, in the presence of a strong acid, it should act like a base for sure, and there should be a reaction. So now I've just put that back into its original container. I'm not going to wash this. What I'm going to do is I'm going to add some more water to dilute and bring that back up or down to a pH of 1 and let that sit for another week. I'll do the same thing for this one and also for this one, and we'll catch you next week. 24 hours later, the precipitate lees, 200 mils, maintaining pH 1, still in suspension, and there's 120A2, reconstituted nodule, taken to pH 1 and then trying to get it back up to 8.5. Today is the 16th, and last time I tested it was 14th, that's why you can see 14 there. We're still sitting at 1.8, I think that was, maybe that's sitting on 1.9 now, just stabilising at 1.9, and it's looking like way more precipitate than what I started with, so I can only assume that's just a greater volume, less dense. But push on, another 5 mil. Just a supplementary curiosity. I don't know if you can see it, but the level of the fluid in the piggyback jar is lower than the level of the fluid in the main jar. So it's as if the main jar is pulling the fluid out of the piggyback jar. It's not a parallax error, it doesn't matter what angle I'm on. Holds true. Well, can't take a trick. It's gone to 10.3 overnight. So I overshot the runway. You can see that it was sitting at 3.0 yesterday, the 18th. And today, 10.3. So I'll just have to stop it there and decide what to do. Okay, I've got it off and stripped it down. So it seems to be a bit stratified, but that could be just from jiggling it a little bit. So you get 10.5. What I'm going to do is I'm just going to stir it up to see what happens, if anything. Oh, look at that. I don't know if you can see that, but the pH has gone to 12.3. I'll just see if we can focus it better. 12.3. So we were getting some layering. Yep, that's 12.3. Well, I think I'm going to have to do, I'll continue with this experiment, but I think I'll have to redo the whole thing back with a stirrer. Here's something else I haven't seen before. It's been less than an hour and it's just dropping out very quickly, so the precipitate's very dense and very discreet in the solution. I'll have to go to work now. So 128.2, been sitting at pH 12.3 since about the 19th, and it's the 28th today, so it's about 10 days. Nice and clear, so I'm going to rack that off and discard the precipitate. It's all happening now. Should be done in a few minutes. That's that all racked off. As you can see, you can pretty much get it all the fluid. Tip the precipitate out, a quick wash of the jar, and tip the collected fluid into the original jar. More convenient size. It only took 11 ml of hydrochloric acid to get it down to 8.5. It's moving around a little bit, but 8.5 to 8.7. And there is a very fine precipitate. It is growing as I watch it. I think you can imagine, you can see that forming. So I'll just leave that there now. And I'll just monitor the pH, make sure it stays around 8.5 to 9, and I will bring it up to 10.7 as well. I'll just let it stabilise like this, I think, for maybe even overnight. Okay, we've let that settle overnight, and see there's a very fine precipitate. I'll see if I can get a depth perception on that. That looks like about 5 ml. Slightly yellowy brown, but that could be the dye from the water from the shoelace. Okay, I'll proceed to bring the pH back up to 10.7. It'll only take a few mil, I think. As expected, it didn't take much to get to 10.6, 10.7. Just using 2 meters there just to be sure. So 1.05 mil of 30% sodium hydroxide was able to do it. And just try and catch the Ormus forming. Look, I think you can see it there. I'll leave that. And here's the setup I'm using this time. Just using a magnetic stirrer instead of a mechanical stirrer. It doesn't really make any difference. And my mechanical stirrer broke, so I have got parts, but in the top section, instead of a piggyback jar, soaking it in, then I come up with the idea of just getting one of my syringes and cutting off the plastic tubing about there, shoving a shoelace through it to slow it down, and that's been sitting there for about half an hour. Can't see any movement, so that's how slow it's going in. And this way I'll know exactly how much has gone in with a piggyback jar, unless I tipped it out and kept a log of it that way. I wouldn't know, but with this method I'll know exactly what's going in. So, what a pain. It looks good, but even though it's clear, we have overshot the mark. I was looking at it, it was pH of 6, it was starting to turn. Just went out of the room just a little bit too long and missed it. I don't know if you can see that. Anyway, it's sitting on 10.7, 10.4. Oh, there you go, that angle. So, nothing for it but to start again. So the way to do this is to rack this off. Now it's the precipitate that we want. We'll rack it off, add some more water, 500 ml say, and add acid again, hydrochloric acid, pH down to 1, dissolve it, and redo it again another few weeks, and hopefully when it's running towards the end, then be a bit more careful. Well, it's now the 3rd of August, so you can see from the 19th to the 6th it's been quite a wait for this to dissolve, and it hasn't all dissolved. There's still a thin amount of sediment on the bottom, and glass looks a bit murky, but that's just really adhering to the glass. Anyway, so I'll rack that off now and start again, and really you wouldn't expect any M state to be in that precipitate, so in a way we've hopefully got rid of more of what we don't want. Bring 120 AB racked off at pH less than 1, and just bringing it back up now. We're about 1.3. Notice it's cloudy already, which is not all that unusual. Usual sodium hydroxide concentration. So there you have it. I've got 220 ml in already. For some reason the pH went all the way down to 0.1. It's now November, and it was 3rd of August last time when we racked it off. Been quite busy going overseas, and I've had my buffer solutions by testing my pH meters because I didn't believe the readings I was getting. You can see quite clearly there, 1.3, and starting off at 0.1. It rose a little bit at the start, then it went back down again to 0.2, and I'm only just now getting it to rise again. No real explanation, but we'll just follow it through and see what we get. And now sitting on 8.5, 8.6, and we're looking at 226.8 mil. Well, the time has come on a botched 3-stage precipitate, where on the first stage I ended up with a nodule, which I carried in a separate line to dissolve that or get any possible M state out of it. And a 3rd stage which botched up itself, went over, what you get when you're not watching. Had trouble redissolving that at pH 1, so split it into 3 and tried 3 different lines of approach, and with difficulties, meaning I split it again and tried something else with the leads, and I've allowed it to settle over 3 or 4 months now. And this one over here I've taken through to its 3rd stage. It produced more precipitate than I thought it would. One over here didn't clear, was the only one that didn't really clear. I'll probably leave that one out. So I'll probably rack everything else off and bring it back together, because the only reason I split it was to try and see if I could get it to dissolve quicker. Combine those remaining 4 and run it through, and then add it to this one here. Combine it all back together, and I'll do the same with that one.